Good day, everyone. My name is Alberto Muner, and Happy New Year. Today is January 1st. Time check is 9:52 a.m., January 1, 2024. So today's video is about my SRT521 project phase 1 and 2. We're using Naïve BAYES for the email spam filter. So for introduction, really what it's saying here is there are more and more spam, phishing emails, malicious emails that are being in the wild right now. I mean, going around the internet, and also, like those spam messages that can be the same category as this, although it's just a relative of phishing emails. And so that's what we're going to do. We will filter those malicious emails versus legit emails using Naïve BAYES email filters. And it's a machine learning algorithm to help us battle this phishing emails, right? So there is a data set again that we downloaded. And it has 3 fields: subject, message, and label, right? And as we know, the label 1 is spam and 0 is ham, so we'll look into that shortly. It says here that there are 2,893. Now that is 2,412 legitimate messages, right? And this data set was downloaded from this website, okay? And the objective of this lab, our project, is to construct an email spam filter using machine learning technique and to evaluate its accuracy on both test data and new data. The algorithm you should pick is, I picked Naïve BAYES with the classifier multinomial Naïve BAYES classifier. Just to reiterate, just letting you know that I combined phase 1 and phase 2, so this will be a long video. All right, so without further ado, we just begin doing the step-by-step, and then we start with task 1, dataset preparation. So this is the dataset that we downloaded from Kaggle, and as you can see, there are 3 fields here, 3 columns: subject, messages, message, and label. And as you can see, these are the label for, the record for the label, 0s and 1, pretty much. They're kind of distorted because the message and the subject level, they're like many words and text entered to it. So I hope will not confuse you. Okay, for task 1, you will have to load the data into the Python program and do the necessary conversion, look for any missing values, and get rid of those records. So this is the part where in my program has done that, right? And I dropped the columns which one I don't need, and pretty much just to let you know, guys, I combined the subject column and the message column together because I don't see any use of them separated, so I just combined them for faster processing. So technically saying, I dropped or I deleted those columns and save it to new file, right? All right, so this is the part where it says that. It says that prepare some graphs to perform text analytics and data and to show other useful values. All right, this is about still preparing the dataset. That I combined the message, like I said earlier, and also right off the bat, I also created new columns called category and label its record whether it is ham or spam based on the label column. And this is the part where it says that in my program. All right, so after that, I saved the program and deleted the label column. So what I have just right now is the category, right? Because this is the category column is the new column I made for spam and ham, right? Okay, this I just do it manually, right? So now this is the file I will use from task 1 to 5, pretty much, and also task 6. As you can see here, also the message column has the combined contents of the previous dataset file, which is the subject and message. All right, guys, and so it says prepare some graphs, perform text analytics on your data to show other useful values. And here's the output. Okay, and let's see this in action. Actually, I did this part in task 2, so you can see this in task 2, right? So I'm just going to run the task 1 program for you to know, and also the way how I transform the dataset. Okay, so this is the original file that I downloaded from Kaggle, and then I copy it so that I preserve the file, and so I'm using this file right now. But this is an exact copy of this file, just to let you know, the message CSV. So then after that, so I inputted this file over here, and I did the one that I just explained you earlier over there, but I combined it, and then I save it to this new files, which is the one I showed you earlier there, the combined columns, right? So this is my task 1. So let's run this and see it in action. All right, start task 1. Let's increase the font. All right, guys, from task 1, this are what I imported. This is the scikit-learn multinomial that we need to do, and we load my new dataset. And in order for us to, it says that we will have to do some analytics. So right from the bat, we will have to display some graphs, it says here, on your data to show some useful values. So we will have to do this now, right? And at the same time, if there's still noise in the dataset, I just have to do this one, right? Like missing values and so on. All right, so this is the Naïve BAYES, and preparing the data, and we use this count vectorizer for a model, and we fit the model, right? And we have this classifier multinomial NB, and here it's start to predict for us, and then it's gonna print an accuracy for us, right? How the machine analyze our data input, and it should display a graph right here. As you can see, guys, I ran task 1, and it created an accuracy of 0.987, and here's a confusion matrix, and it predicted here, right, 466 of spam, right, and also it labeled ham and spam, right. Moving on to task 2. It mentioned here that it has 2 features, but actually I combined it to one column, as I mentioned earlier. The column is now methods. For spam filter, I need to have individual words along with their frequencies. I perform necessary operation, need sets as extracting individual token, remote punctuation of all stop words. Okay, and here's the output of my program, right? Here we go. We will see that in action shortly, right? And also these tokenizer, like the program will tokenize, like itemize one by one the words that is in the message, and I get use of the NLTK platform language parsing. And so actually this has been done clearly in task 6 program, but here's what it says there, right? Feature transformation using NLTK and the word tokenizer. Okay, so you can see that in task 6 program, right? And the scikit-learn over here. So a lot of scikit-learn library and modules have been used. Okay, so and I showed you that earlier when I split the data, right? So I can just take this one and put it in the upper part. So moving to task 2 program, right? So what I've done is on task 1, I built on top of task 1 what else needed in task 2, right? So what is needed there is that the use of tokenizer, right, over here, stop words. Oh yeah, this is the feature transformation. Okay, what is needed here is to individual words along with the frequency. Okay, so individual words, I've used this part, right, and also remove stop words and also punctuation, and convert to lowercase, right? And lastly, from task 2, this is how I split the data, guys. And so it should show to us the accuracy of the NLTK features, right? With the NLTK features, and of course Naïve base. Okay, at this point it mentioned that we will have to get use of NLTK platform, and so this is the Naïve base where with the NLTK features, right? Converting the text data into numerical features using count vectorizer, right, which is we imported earlier, and we're using this too, all right, as required in every task. Yeah, we don't need a graph in task 2, so let me just comment out this one. So we just need this one printed pretty much. Okay, let us run task 2. Okay, guys, as you can see, this is the output with the NLTK features compared to that without the NLTK, just the Naïve base itself, and it has accuracy of 98.58, which is a little lower because this one is 98.7654, right? Okay, let's move on to task 3. All right, task 3 said to train the model, right? I'll show that shortly. Train the model, use the given data to train the model. Your program should process subject and email message, decide value for label to be 0 ham or 1 for spam, right? Alright, so by the way, using this library or module, we need to be online all the time. So let me just uncomment that one. And okay, moving on to task 4, right? We will have to test the model again, test data, compare the result by printing and predicted actual value, and finally printing the model accuracy, right? Same thing like we did over here, and plot the percentage of spam and hams and identified correctly versus incorrectly. So let's see this in our program. Task 4. Okay, guys, so on this task 3, so the label, which is we dropped it earlier, we deleted this label. Now this task, it wants us to create a label and put a value based on the Naïve base with the NLTK features. Let's see how this performed to us, right? So basically, let's go back to our program here, right? It's gonna also plot for us, but it will like predict for us based on the split y test and x train, right? And it's gonna output to us its prediction. So this is the output of the task 3, right? As you can see, I run it there. All right, originally this is how my data looked like. So it input the combined CSV over there, right? And then this is how it looked like. And then after this is for the past task. Now after it classifies for us, right? This part, right? See here, this label, it just switched a little bit far, but this line belongs to that label. So it predicts for us, it reads, and this is the actual value, and it predicted right for us. And its prediction, it's like almost 99%, you can say, 0.99% accuracy. The same thing, these are the libraries and modules that we imported. Oh yeah, this one. Alright, let's put it this way. So we will have to print the model accuracy, and it's here, and then plot the percentage of spam and hams and identify it correctly versus incorrectly. So this is how the program executes, guys. So I put the task 4 over here, and as mentioned here, we print out the model accuracy, right? 988, right? This is still with the NLT key features, Naïve base, right? And here's the graph, right? So it's predicted. Let's move it here. All right. So after closing the other graph, let's put up the next graph and plot the percentage of spam and ham identified correctly versus incorrectly. So here we have this, and it's correctly identified as this accuracy. Explain that here, right? And the graph shows that there too. Okay, guys, moving on to task 5, the test the model new data. Let the program read email command prompt and try to label it. And the output of this model should be message saying the given email is spam or not. Data should then be added to the training model and perform steps again. Compare the result of this phase with the last one to see if your model is improving with new data. All right, so let's do that, guys. Let's look at that into our code. And so this is saying libraries and modules. Okay, so basically what it's saying here is our program will ask to enter message body of the message, right? And it will classify whether it is spam or ham, right? So this is the part in our program where it does that, enter email, and then it's gonna label for us. It's gonna predict, right? It's gonna read the email that we enter, and it's gonna predict whether it's ham or ham, and then it's gonna add the data into the training model. All right, that's what it says there in the task, right? So this is how our program does that, and then it has to retrain the data that we have, because this one is, I still build it on top of from task 1, task 2, task 3, task 4. So I retrain the data again to this side, and it should print us this model accuracy and the updated data set category. So as you can see, guys, it's asking us to enter a body of an email message, right? And then it's going to classify for us. So to do this, let's just try to test this from the data set itself, right? So to do this, I'm going to copy this. We know that this is spam, right? But there's no label over here, right? So let's see after. He's going to check it for us whether it's going to say spam when we enter into the input, right? So let's just try to save that here. And the given email is spam. So it identifies itself, right? So what if we're going to put another email that is a ham, actually? So let's try that. So as you can see, guys, here, I run the program again, task 5. And let's get a legit ham email in our data set. So we know that this is ham. So we just copy and paste that. And it says that it is not a spam, right? Which is correct. It is a ham, right? So that's task 5. Let's do task 6 now. Okay, task 6 is the last task. So the program should implement some adaptations so that more recent training examples are given higher weight than older ones. Your program should provide some ways for the user to adjust the trade-off between false positive and false negative errors. This could be done by either through command line argument or the configuration file. So basically, I will do this to the command line, right? So basically, what it's saying is that if the machine identified it as a spam, but it's actually not a spam, then I will have to label it that it is a spam, right? And then it will record it so that the program will record it so that when I ask it again, it will identify correctly as a spam. So let's see that in action. But first, we'll just going to see the part of our program that does that, right? All right, so this is my program here, right? Adjust the trade-off between false positive and false negative errors, right? And then we train the Naïve base classifier again with the updated, adjusted class priors, right? And then it's going to print the model accuracy over here, right, for us. And then that's the model, right? And basically, let's see this in action. So we go to this this line here. So I copy the content of this file. So we know that this is ham email, legit email. So I copy the content of that email here in my notepad. That's how big it is, and we know it is ham. So let's say later on we found out that this email is actually spam, right? So we will have to adjust that in the back of the program, right? So let's run the program, and I just run it for you guys right there. I use task 6v1 to accomplish the task 6 bonus task. And so yeah, it asked me to enter the new email here, right? And it says that it is not spam. Now it's asking us to adjust the label, right? 2888. Let's see if that is actually 2887. Okay, I went to 2887. Oh yeah, it didn't show here. Okay, so we're gonna adjust that. It is. We will just put spam, right? But our data set is not a spam, right? It's actually saying ham, as you notice here. So we're gonna label it to spam. So we will put 1 over there instead of ham. Okay, so it says it's updated now, right? But it's given us that the model accuracy on the updated data set is this, right? Because it's in the data set that it is actually ham. So we will just have to update it anyway. And now it get updated, right? It gets saved in the memory. So we just have to enter the same email, see what it says right now. And it says the email is spam because we override the dataset label, right? And the program used the new label. So with that, I thank you very much for watching my video, and Happy New Year, and I hope to see you again next time. Have a great day. I'm just gonna exit.